Okay. All right. Greetings. Welcome into my channel. I am Professor L, and this is live stream for math help. So if you're out there and you need help with your math, maybe I can help. Maybe I can't, but I'm willing to try. In the meantime, I am going to be talking about a fifth degree polynomial and hopefully sketching a good graph. It's called a Quintic function. And so, yeah, I didn't realize that it had a name. I figured it did. That's new for me. So a Quintic function is what we're going to be looking at. So moving on from the fourth degree polynomials. And yeah, so we'll look at this odd function. It's to the fifth degree. So if the odd number of exponents means it's an odd function. And an odd function will tell us end behavior, whether it's even or odd is going to tell us end behavior. And I guess I'll go ahead and get started and just informally start talking about this and trying to remember what I can about these higher order polynomials and sketching the graph of them. And we'll see how it goes. About a little bit over a month into my little project here where I've been hosting these live streams. And really just practicing, getting used to the platform. I haven't really done a whole lot to advertise this little stream that I'm doing, so not a whole lot of people, there's not a whole lot of people that know that I'm here. But just practicing, I'm really out of practice, so I feel like that this is good for me to start out slow, whether I can already tell that I'm starting to get a little bit better at the math. And yeah, so this is just me informally getting to practice on my board, forcing myself to do the math, because in a busy world where there's so much to do in a day, I wouldn't otherwise find myself doing the math, but I need to be. All right, so we'll title this one Graphing a Quintic Function. All right, Quintic. And I just want to double check the spelling now for some reason. Of course, I don't have it anywhere handy. Quintic polynomials. All right, it looks like I did good. I passed the first test I can spell. All right. It's not an S. I don't know why I always do that. It's just one function. I tried to find a good one, and I'm either going to do a really complicated one or a really simple one. So I don't know. I haven't decided yet. We might start off with a more complicated one and see where it goes. And if I can't get it, because I haven't really looked at the function much, so I have no previous knowledge of playing around with this function. I was just asking ChatGPT for a fifth degree polynomial with real roots. And I can't remember if this one was the one from my calculus book or this one was the one I got from the AI. There is a simpler one if I can't get this one to cooperate. But this one should have real roots. Let me see. 2x to the fifth minus 3x to the fourth plus x cubed plus 4x squared minus 5x plus 6. And I really hope this one works out. All right, so what we're going to do is we're going to try to not lose sight of the end goal, which is to sketch the graph of this quintic function. And I want a really pretty, clean graph. I realize it's going to be a rough sketch, but I want to try to get as close as possible. So I'm not going to go into too far detail because I might end up having to erase this coordinate system. So get our basic Cartesian coordinate system here going and see what happens. All right, so what I want to do is, very first thing, I would like to see the zeros of this polynomial. So remember, what we're doing is we're sketching the graph using a table, and we're going to develop the table. So maybe right now I'll just start out with the table here, and it's going to probably get a little bit bigger. But the very first thing I want to do is I want to find out when x is 0 and when y is 0. Now, plugging in 0 for x is a lot easier. We'll start out there. But if I let x be 0, all of these terms that have variables are going to drop out. But just for fun, we'll go ahead and do it. So I'm just plugging in 0, -3 times 0 to the 4th plus 0 cubed plus 4 times 0 squared minus 5 times 0 plus 6. So we've got 0, 0, 0, 0, 0, and then we have plus 6. So when x is 0, y is 6. And we've got our first critical point on the graph. 1, 2, 3, 4, 5, 6. And we've got our first little ordered pair, 0, 6. Now the harder thing to do is to allow the function to be 0. Because if I replace f of x with 0 now, remember y equals f of x. And when y is 0, what is x doing? So we'll have 0 equals 2x to the 5th minus 3x to the 4th. Actually, I'm just going to go ahead and rewrite this now because I like all my variables to be on the left. So what we're doing is we're just setting it equal to 0. So we'll say 2x to the 5th minus 3x to the 4th plus x cubed plus 4x squared minus 5x plus 6 equal 0. Well, now we're going to have to do a little bit of algebra. And people that don't understand math, they think it's trickery. They think it's magic or something, but it's not. And hopefully it works out. I don't know if it's going to or not. I hope it does. But what we're doing is we're going to use the rational roots theorem. And this is the second time using this theorem for me, so in a while. So I feel like I'm going to do a little bit better. So what we're doing is we're saying P and Q, and I got it wrong last time, but I won't get it wrong again because I learned P over Q. And so that's going to be 6 over 2, which is 3. And then every factor of 6 and 2. So that's 6. We have 1, 2, 3, and 6. And then 2, I feel like I've already done this one. Maybe not. Okay. 2 is going to be 1 and 2. And then you're going to make all your fractions if you can. So 1 over 1 is 1. That's a repeat. 1/2 is on there. And then 2 over 2, 3 over 2. And then 6 over 2 is 3. And then it's the plus or minuses. So there's no repeats. Plus or minus, plus or minus. And this one's looking a lot like that 4th degree polynomial, but it's a 5th degree. So and let's see. Let's see. What do we want to start? We'll start out with plus or minus 1. And so what we're doing is we're trying to take each individual value. The rational roots theorem states that if P is a factor of the, they call this the constant term. It's the x to the 0 term. It's always the caboose. It's the last one. It's without an x. It's the one without a variable. If P is a factor of the constant term and Q is a factor of the leading coefficient, then in reduced form, which would be 3, or this would be, 3, then what it's saying is that all of these possibilities of these numbers, the factors of these numbers, are potential zeros. So it's like a place to start checking. It's the process of breaking this polynomial up if it can be. So there's another theorem that says if you evaluate the function at that possible potential root and it equals 0, then it is a factor. So I'm just going to start with positive 1 because that's 1 is the easiest thing to calculate for me. So that's a good place to start to figure out what's going on, behavior of this function. It's also not a complete waste if it's not a factor, because what we're doing is we're sketching the graph of this curve. I'm going to want to know where the graph is existing at 1 anyways. So it's a win-win for me. But all these are the potential zeros, so that's where I will start. So 1 and -1, these points that are real close to the origin are usually a starting point for me. What's going on right around the origin? Okay. So we've got 2 times 1 to the 5th. I'm going to try and write this kind of small. Minus 3 times 1 to the 4th plus, this is 1 cubed plus 4 times 1 squared minus 5 times 1 plus 6. Okay. I just noticed I'm looking on the screen and that doesn't look right. So like that, Quintic. All right. So we've got 2 times 1 minus 3 times 1 plus 1 plus 4 minus 5 plus 6. See what's going on. And my favorite thing to do here in this case is just add up all the positives. So we've got 2, let's see, we got 10, 11, 13, and then we've got -3 and -5 is -8. So what is that? Positive 5? 13. All right, so it's not telling me the 0, but I did get a value. So we're going to go ahead and put this in here. 1, 5 is on there. So 1,5 is right here. And so I'm going to count that as a win. It's not a 0. It's not helping me factor it. But it's a win. Let's go ahead and put in here f of -1 now. And figure this one out. And really, I'm not in a hurry to get this one done. So I feel like we'll start sketching it, and this will probably take us a couple days. But let's go ahead and do this real quick. Let's see, 2 times -1 to the 5th power minus 3 times -1 to the 4th power plus -1 cubed plus 4 times -1 squared minus 5 times -1 plus 6. All right, and hopefully I did good on the math. Also, that looks like an E. It's not an E. It's a Quintic. Right. So now we're just going to go through and figure out whether we have positives or negatives. An odd amount of negatives is going to give you a negative. So this is 2 times -1. An even amount of negatives is going to be a positive times a negative. So that's going to be -3. And then an odd amount of negatives is going to be negative. And then that one's going to be +4, positive. 2 negatives make a positive. And then 6. So we've got -2. And then we'll try to add some of these. -4. And then 15. So what's that? We got -6 plus 15. 9. 9. Okay, f of -1 is +9. So we're going to go ahead and put, we'll just put it in here. It's going to be out of order. -1, I have to rewrite my table, is 9. +9, 6. Make this a little bit bigger. See, 7, 8, 9. That looks decent. And then also, I mentioned the 5th degree polynomial controlling end behavior. So there's also a theorem that says it's just about the end behavior of the function. If it's even, it's going to have symmetry with respect to the y-axis. And if it's odd, it's going to have symmetry with respect to the origin. So odd functions have an end behavior if they're not having any kind of transformation in the graph, and the graph isn't shifted in any way. It'll be coming from the 3rd through the 1st quadrant. So I know my end behavior is going to be headed towards negative infinity through the 3rd quadrant and positive infinity through the 1st quadrant. And I know that because it's got the odd symmetry and it doesn't have a reflection in the graph. It's not negative. That leading coefficient is not negative. If it was negative, it would be flipped. And it would be this direction. So understanding like the order of the polynomial, and it helps you get a visual idea of the graph. All right, so let's see what I want to do next. Well, I guess I could just keep developing these points. I could check a couple more, and then we'll probably stop. I'm trying to move away from the calculator. Eventually, I would like to be able to graph these functions completely by hand without the use of tools. That would be cool. But those tools, we don't realize how dependent as a society and individuals we are on the tools. All right. Well, we tried plus or minus 1, and we didn't get a 0. So let's try 3. Well, let's skip 2. Let's go to 3. Now, I would really like to factor this thing. I'm also going to erase this. I don't need this in. I want to put that factored form right there. Okay, hopefully we'll get it. Maybe it can't factor. If it doesn't have clean zeros, it's going to be a booger. So we'll try 3. 2 times 3 to the 5th minus 3 times 3 to the 4th plus 3 cubed plus 4 times 3 squared minus 5 times 3 plus 6. It's a lot of terms. I had another 5th degree polynomial picked out. It was a lot easier. Maybe we should have picked that one. All right, I have no idea what 3 to the 5th is. So what I'm going to do is I'm going to go ahead and store this polynomial in my calculator. 2x to the 5th minus 3x to the 4th plus x cubed plus 4 x squared minus 5x plus 6. And putting 3 in for x. All right. Ooh. 3 is definitely not it's saying 297. So maybe I don't have it incorrectly. Let's see. 2x to the 5th minus 3x to the 4th plus x cubed plus 4x squared minus 5x plus 6. Yeah, so definitely not 3. Let's try -2. -3 first. Hang on. Yeah, so yeah, it's at -699. So 3 is not going to be an option. Let's see what's going on at 2. That's the thing about these higher polynomials. They pick up speed fast. And it's already gone to infinity by -3. So we're going to back up. I'm not even going to bother trying to do 6. We'll do 6 just for fun. Well, since I already have the function stored, I might as well. Yeah, so we're already at 12,000 at 6. So 6 is not going to be an option for 0. 3s are not a 0. We only have a couple more whole numbers to try. So we have 2. So all we're doing is replacing this with 2. And that makes it a little bit easier. We do it that way. 2, 2, 2, 2, and 2. And I'm going to put it in the calculator real quick. 2 stored for x. 36. And -2. -88. Ooh, yucky. All right, so we might be stuck dealing with some fractions here. So 3 divided by 2. 10. So at 3 halves, see, 3 halves, we're at 10. So I need to clean up my table and rewrite it because I want to know what's going on here. So let's go ahead and go. We'll start out with negative 3 halves. Okay, so all right, positive, negative, hang on, negative 3 halves is at negative 45 over 4, which is approximately 11.25 negative. So right here between 1 and 2, we're already at here, negative. I'm getting well ahead of myself here. So this point is on my graph. And then negative 1, I was already at 9. So we have an intersection in here somewhere. Because, let's see, negative 1, I'm at 9. So since I've gone from positive to negative, then in here somewhere I have a crossing. So we'll scoot it over just a little bit. But I have this kind of thing going on. Good, already getting a good sketch of this graph. And then at positive 1, let's see, at 0, we're at 6. So hang on, negative 1. I want to do negative 1/2 next. That's the one I want to do next. Negative 1/2. So f of negative 1/2. That's going to look like 2 times negative 1/2 to the 5th minus 3 times negative 1/2 to the 4th plus negative 1/2 cubed plus 4 times negative 1/2 squared. I'm out of room. Let's see where I'm at this table. Let's scoot over. Negative 3 halves. Comma y, negative 3 halves, negative 1. This was negative 45 over 4, 9, and I don't know what 1/2 is. I'm just scoot this table over. All right. All right, negative 1/2 minus 5 times negative 1/2 plus 6. And we'll let the calculator do that work because it's going to, I'm already at 30 minutes. That's a lot. So, you got to square, or you got to raise to the 5th power the numerator and the denominator. So this first term we'll do real quick, but see, 1 to the 5th is just 1, and then 2 to the 5th, see, 2 to the 4th is 16, that's 32. And then it is going to remain negative because of the odd amount of negatives. But you could see how, I guess we could do it real quick. -3, and then that's going to be positive 1 over 2 to the 4th is 16. 2s are not that bad. Let's see. Well, plus a negative. We'll go ahead and just call it negative. Well, we'll leave it, we'll leave it for a second. So 2 squared is 8. And that's going to be negative plus 4 times 2 squared is 4. So that's 1/4 positive. Plus 5 halves plus 6. That's going to reduce down. Half of 32 is 16. So that's -1 over 16. 3 doesn't divide 16 yet. No. -3 over 16. I'm going to go ahead and just make I'm going to make well, I don't know, I'm having like a brain glitch or something. My brain what am I trying to say? Okay, I'm going to put them in equivalent fraction. Yeah, equivalent. That's the word. All right, so that'll be 2/16, -2/16. It'll make it easier to also. So 4 times 1/4. We're going to reduce that one down to 1, and then we'll put that plus 16 over 16. And then let's see, 2 times 8 is 16, 5 times 8 is 40. And then 6 times 16, I'm going to use my calculator. 96 over 16. That makes it a little bit easier because then we can just add up the negatives and the positives. So that is, let's see, 3, 5, 6. -6, and then 40, 56 plus 96, 152 over 16. -152 -6. I'm getting 146 over 16. And that reduces down to 73 over 8, which is approximately 9.125. So negative, let's see what that was, -1/2. -1, we're at 9. And then -1/2, we're at 9.125. Wait, +9. Yeah, so we're just up a little bit more at 1/2. So it goes up a little bit more is what it does. That might be a maximum. Regardless, so we have the 0, we have a maximum 5. So what we're going to have to do is we're going to have to figure out what it's doing at positive 3 halves. Wait, we already know that, don't we? Did we already do this one? Positive 3 halves is 10. We're back up to 10. Come on, 6, 7, 8, 9, 10 will be here. So positive 3 halves, we're already back up at 10. It looks like there might be another thing going on in this graph here. And then at 2, did we already do 2? Oh, we did. It's 36. Okay, I don't think that this graph has any more intersections. I think that it's just going to shoot up. We can check because 3, we already did 3 also. There it is, 29, yeah, it's 297. All right, so this is pretty much the sketch of this one, this quintic function. This one was pretty, not too bad to graph. We didn't really do a whole lot, but I think it's only got one clean intersection here, and it's not a real root. Yeah, so I think what we'll do is I might go ahead and call that good, because it's almost 40 minutes in. What I probably will do, since I'm not real happy with this one, is I had another quintic graph picked out. We might go ahead and play around with that one tomorrow. I'm trying to not plan too far ahead and try and just play it by ear. Also, if anyone is out there and watching and they do want to show up, or if you have a suggestion on something that you would like me to look into and maybe present, as well as like a specific problem, you want more, a topic discussed, you can also put that in the chat as well. It's just me playing around, trying to be useful, and yeah, doing math. And also, it's much more fun to do math with other people. So yeah, trying to use social media for education purposes, of course. And yeah, so we'll go ahead and call that good. And what I'll do is I will be back here tomorrow at the same time, same place. Yeah, so remember 6-7 p.m. Central Time. And I will see you next time. And again, thanks for watching my videos. And yeah, till next time.